Hey everyone, so this is my Physics 1 Lab 4 video. So the purpose of this lab was to observe the motion of a mass hanging on an oscillating spring and use it to calculate kinetic and potential energy, and then use those to calculate the total energy of the system. So some models we use kinetic energy, gravitational potential energy, and spring potential energy equations, and then just the position velocity update formulas. And the main lab result was the total energy of the system was 0 joules, but the gravitational potential energy and spring potential energy were opposite one another. When one was at its maximum, the other was at its minimum. So some physics principles, like I said before, kinetic energy, gravitational potential, spring potential, and then just position and velocity update formulas, just to show like the position velocity as time moves forward. And the system and surroundings in this scenario, the system was the mass, spring, and the earth, and then the surroundings were just nothing. Initial conditions were the mass was 0.402 kilograms, and the rest of the information, besides the 6.83 newtons per meter, were from the tracker data. So the experiment, a mass was attached to an oscillating spring, and it was released from rest. And the tracker was used to extract position data. And we didn't use the full video. We began tracking after the mass was released, and then we just observed the position of the mass over time. So in the computational model, we put in the mass and the initial position and velocity from the tracker, and then we updated the kinetic, gravitational potential, and spring potential energy equations so they correctly reflected what the actual equations are that were shown earlier. And then total energy is just the sum of each of those three energies. And then at the bottom there is the position update and velocity update formulas, just like I said before, to show how those change as time goes on. And then up here in the top corner, we have L and L hat, which are used in like the spring, energy equation, because L and L hat are used to L and L naught are used to calculate S, which goes into the spring potential energy. All right, so on the right here, we have the difference between the model and the experiment position of X and Y. So in the blue is the model and red is the experiment. So they're both similar, but they're definitely, the experiment isn't as perfectly smooth. And in the case of the Y position, not necessarily as tall, doesn't have the same amplitude as the model. But in the energy graph, you can see that the total energy is 0 joules the whole time. And the spring potential energy and gravitational potential energy are opposite one another. And there's just a little bit of constant kinetic energy because the spring is constantly moving, or the mass on the spring is constantly moving. So some potential error in this lab, just video extraction or video data extraction from tracker, and then editing the code to correctly match the tracker data. It's always kind of a struggle. So there could always be error involved in that. What does it mean? The energy principle was satisfied because energy is not created or destroyed. It's just converted between gravitational potential, spring potential, and kinetic energy. And the total energy is always 0 joules. So no matter what type of energy it is, there's always the consistent total energy of 0. And then the period of oscillation, I calculate this by looking at two peaks, and the X position and the Y position, and then calculating the time between the two. So they're similar, but they're not exactly the same because they're on a spring. So there's a difference in the period of an X position oscillation and then just the spring moving up and down. So in conclusion, the system has spring potential energy, gravitational potential energy, and kinetic energy that adds to a total energy of 0. And then the type of energy is constantly changing. So potential, gravitational potential, or spring potential, gravitational potential, and kinetic energy, they're constantly changing. There's not always it's not always completely gravitational potential or completely kinetic, but there's always the consistency of there being a total energy of 0 joules. So that's it. Thanks for listening.